what if about the gift contract? We created a UTXO with a gift for someone, and let's assume that this person doesn't know or how to collect it. There's a way to automatically make the smart contract be consumed by the person that has to be has to receive the payment. So no, the blockchain is a passive entity. It doesn't perform any actions. The only way the blockchain does something is if a transaction is made to the blockchain that creates those changes. So the only two ways you have to make the payment to the person is that either you have some off-chain way that some cron job or something that queries the blockchain and keeps seeing if it can be consumed, and as soon as it detects it's consumed, it creates the transaction for the person. Or another way could be to make the gift contract in a way that incentivizes someone else to create the transaction. So you could be paying, I don't know, 1% fee to anyone that creates this transaction, so the actual person can receive the gift. So in that case, anyone that sees the transaction is incentivized to create the transaction, and so the beneficiary can get his money. The smart contract needs to be a bit different, but still someone from the outside the blockchain, from the off-chain, who has to perform an action for the off-chain to actually change. We have a comment and a question. The comment, Manuel says, hello, it's okay for me. I did the homework okay, and the Lucy part 2, awesome. I'm using Bluetooth apps with Nix, great score, thank you. Okay, awesome. You can use Nix. You don't have to use the Docker image. You can use Nix. You can use Bluetooth apps if you know how to do it. And so awesome. We are glad you're enjoying the course. And Dennis is asking about the status of the Bluetooth Pioneer NFT certificate, the one we will be able to unlock after completing the course. So I'm not sure if that is already been settled by legal.
Yeah, I'll take that one, Robertino. So there's a couple of options we're exploring here, and Lars has a couple of nice ideas around this. We just need to be careful with the NFT issuing, that we're talking to our legal department about it. So we will keep you all posted. There's no specific update right now, but it is definitely on our list of items to action.
If there are no further questions, we could answer the question from Discord on the Redeemer and like how to format data in Lucid and in general, perhaps.
Yeah, good idea, Thomas. Thank you.
Let me grab it real quick.
Can you share it?
Yeah, I will share my screen if that's possible. Let me just set up real quick. And we also share the question, perhaps. Robertino, can you search for the question? Perhaps
Yeah,
it's
sure.
also in
No problem.
on Slack.
Do you want me to share it or?
Oh wait, I've got it. I've
Yeah.
yeah.
Okay. I share the link so people in the chat can.
Yeah. Why is it not working?
Everyone, okay. Here's the question and the answer. Okay, yeah, it's starting, Thomas. Okay.
Yeah, you can see it, right? So this was the question, and I think it's a good question. So it says, hello everyone. In the Plutus on-chain code, I have a redeemer data type that looks like this. Data handler redeemer is update or mint. So it's an algebraic data type. How can I implement it or write it as an off-chain code in Lucid? And I think it's a valid question, also a question to take a bit of a deeper dive, namely, how is a data type in Haskell actually converted to a datum or a redeemer? And for that purpose, I altered the vesting example of last week real quick, and I added some things just to showcase this. And what I added mainly is we already had this vesting datum, and I added this datum, my redeemer. And my redeemer is an algebraic type. It has two options, option A or option B. And for option B, it also contains a list of integers. And instead of using unstable make is data, I used make is data indexed. And there's a difference between the two because unstable make is data tries to interpret your type and then tries to convert it to a datum. So we could have, for example, if we saw that here, so that if you have print data to JSON and you have a datum, then it will return something in JSON so that it can do that. Now the question was like, how do you do that for like in Lucid? But I think to understand that, you also have to see how it normally works. So besides giving it a loose definition via unstable make is data, you can also pin your algebraic data type by setting the options to different constructors and their index. Specifically, this redeemer has two options, option A and option B. And we can pin option A to index 0 and option B to index 1. And if we do that, then for example, we could have had A. Why is it? It's not showing. So if we define A to be option A, and then look at the type of A, which is a my redeemer, we can now do print data to JSON A. And what you will see is that the template Haskell will convert it to something of constructor 0 because we pinned it at 0. Similarly, for option B, we could have something of B is option B with some list of integers. And if we then do the same with B, it shows as the same, but then with constructor 0 and its fields. So if we just take a quick look back, this option didn't have any fields. Like there was no option besides like it being a type option A. So it had an empty field here, while this option B did have a field, namely a list of integers. So what we saw is that the fields contained a list of integers. And this is how it works. So you can pin that. And with regard to Lucid, how you can do it, Lucid has like, these constructors. More specifically, it has like data, which is either an integer, a string, an array, a map, or constructor, which is the same data as the built-in data that we have in on-chain. And yeah, you can use that just how you would guess it works. So similar to what I just did, we have like just the empty fields. Just that is in this case for the update. That's this one. You would do something like constructor 0 and then an empty list so that the fields are empty. And similarly for like a list of integers with, for example, mint, where we pin it at mint and then index 1, you can do like constructor 1 and then add the list of integers. Note that you have to put an n here to make it the correct type of big integer. So that's how it works, and this is an example. Hope that clarifies it a bit. And if there are any questions, feel free to ask them. Robertino, you're muted.
Thank you, Thomas. There are questions about other stuff, but maybe just wait a couple of seconds to see if anyone has a specific question about this. Or you can raise your hand and talk if you want to. Okay, so we have 2 more questions, and one about Docker and one about on console on where, let's say console live, where a beginner is advisable to join. Can a beginner join now, or is it still late? It's not late. I mean, the course itself, we are releasing each week a new lesson with a couple of breaks for people to catch up, but it's still, you can do it at your own pace. You don't have to go. I mean, if it's harder for you or you get stuck, you can ask questions and keep building at your own pace. So you don't have to actually like keep track of each week, because the content will be there. It won't get removed or anything. So you're good to go. If you're struggling with either basic content, basic concepts, you can ask. And if you're struggling with Haskell, we have a Haskell course you can do as a prerequisite for this one. So depending on how you're feeling, but you feel free to start right now, and maybe if you go fast enough, in just a couple of weeks, you will be catch up. Okay, and there's another question about the Docker image. A few days ago, you mentioned that you split the Docker image in 3 parts. Can you elaborate on that? How do we get the 3 parts separately? Yes. Let me show you actually the code that generates all 3 parts. So like everyone that wants to fiddle around with Docker can actually do it. Let's see. Okay. Can everyone see my screen? Awesome.
Yes, we can.
Perfect. So as soon as you open VS Code, it will check this dev container JSON file, and this file states like an overview of what you need. So the name that appears right here in the corner, a Docker compose file that has more details about which which images have to run and how they interact. The main service, the folder that will be open when you actually open the image. This, as you can see here, you can see that the image opens in the workspace folder. This is hard coded, and a couple of extensions that will be installed for you in the VS Code instance inside the Docker. So as you can see here, we say, okay, Docker compose file is the important one. And here we have services. In the services tab, you have each service that will run. In this case, we have just two services. The Cardano node, this will be a Docker container running in your computer, and the PPP Docker container, that is the one that you actually will use. You will interact with this component. So when you install Docker and you clone this repository and open, the dev container .json will say, hey, I need this Docker compose file to be run. So Docker will go to this compose file and say, okay, we need two services, the Cardano node that is built with this image. So it will pull the image, from the internet for you, and it will provide a bunch of environment variables, and the PPP image that it will pull this image from it. So right out of the gate, you get downloaded two images and they run automatically when you open. So you don't have to get the images separately. Everything runs together. And finally, there's a third part of this equation that is the volumes. In the volumes, we indicate that the node's database and the way that the file used to communicate with the node belong to separate volumes that are outside our containers. So by just stating the same volumes in two different containers, as you can see here, and inside the PPP, and here we're stating both in the same file, we are sharing this file. So we have, at the end of the day, we end up with three different components, two containers that actually run, and one volume that is the one that contains the database, the synced blockchain. The point of this is that now we can change, for example, you can change which Cardano node you use by just changing this image. You can change which Bluetooth Pioneer program image you use by just changing the version, for example. And all this is independent of the actual synced Cardano node. So as if you change any image and you reopen, you will still have everything synced and everything working. The idea is that now we have this modularized, so we can pick and choose what we want in what it works best, and the pioneers don't need to like resync and re-download everything all the time. Any more questions?
No, I don't think so. Does anyone have a different question that they want to ask about anything or any feedback? Oh, great. Thank you, Eric. Nice to hear.
Yes.
Great. We're getting some thumbs up. Also, we'd love to hear any feedback you guys have on how we're using Discord or even the playbook, the additional resources we have, the weekly blog. We're very reactive and we can be flexible. If there's something else you would like to see, feel free to get in touch and let us know. We're happy to respond to what you particularly need from week to week. Okay, I can't see any more questions. Seems like everyone is happy for now. Okay. So if we don't have any more questions, final shout out. I guess we'll finish up for this week and wish everyone another successful week. We will have more questions after the next lecture. That's quite true, indeed. Yeah. Glad to hear it's helpful. Great, and nice feedback on the Docker images. Thank you, Albert. Okay, wishing everyone a very good week. Thanks for joining, and we will all see you soon.